Getting MIDI data from audio is something which has been increasingly common in DAWs and other software applications as our ability to process and understand audio changes. Cubase 12 finally adds this to Cubase, but it doesn't do it in a way which other sequencers have taken. It allows us to turn audio events into events on the chord track, which means you can control it in a different but more flexible way. So let's take a look at how Steinberg have decided to do it. So here we are in Cubase, and we've got 3 examples to look through. So the first one that I want to take a look at is just some simple chords. So this is just some simple chords being played, fairly piecemeal manner, fairly straightforward. So you can see we've just got bar long block chords and then some beat long chords here. These are all chords which the documentation says this should recognize. So we've got just straightforward C, F, G, then we've got C major 7, F major 7 and G7, etc. And then we've got some sus4 and sus2 chords towards the end. So pretty plain fare, I think. Nothing too advanced. So the way to test this is, of course, it needs to be turned into audio, and this will show you the process. So clearly in this case, I'm just converting some synth stuff to audio to then use this as an example. You may well just be dragging samples in, but either way, it will be the same. So first thing, I'm just going to render this. So there we have our straightforward audio version of it, and I'll just solo this so you can hear what's happening. Nothing too exciting there. Some major 7 and 7th chords, etc. And then the end section, we've got this. Bit of cheesy ballad work there. Now the actual action of generating the chord track chords from audio is straightforward. All you have to do is just drag it onto the chord track. So there you see they get analysed, and then we can see the results. So this is possibly different to the way many other DAWs do it. So we can see what's actually happened. Just going to clean up the display a little bit here. And we can see that this first section has been detected correctly. And then after that, maybe slightly different. So we haven't got a D minor 7, we've got a D minor. We've got back to C there, and then the C has been detected correctly, but the C sus2 isn't being detected correctly. And there's some other issues which we'll look at. But let's take a closer look at the way this actually works in terms of the chords which are generated. So as you can see, the chords which have been generated have got this little audio sort of waveform next to them to show that they've been generated via audio analysis. So if we open one of these up in the traditional way and then look at the chord assistant, we can see we get probabilities, because this is the kind of algorithm that doesn't just say, yeah, it's definitely C. It gives you probabilities of what they might be. So it's got this much chance of being C, but then less chance of being some of these other chords, and even less of being some of these others there. If you decide you want to use one of those other chords instead, you can just click on it and it will work as normal. And if you want to edit it yourself, you are free to change it in the editor here. But it does show you that it's still got that audio information there. And if you go back to the chord assistant on the detected tab, you can see you can go back to picking what was actually detected by this. So this is a useful addition to the way that the chord track works. Gives you a few extra options, but you can see that it hasn't been totally successful in detecting everything here. So it hasn't detected that this C has changed to a C major 7, and I actually tried to give it a fair go at it by making sure that this B on top of the C major 7 was really clear to hear. In fact, you can see that the level goes up a significant amount, and all of these have been set to pretty even velocity to try and help it detect the C sus2, but it doesn't seem to have done that. Now, this also brings up another issue, which we'll see a bit later on, is that timing isn't always spot on. So depending on the sound and also depending on the detection in the chord and what seems to be quite a few different variables. Sometimes things will be a bit late. So if we zoom in at bar 9.5, you can see that while the audio and the MIDI actually happens here, the chord detection didn't happen till a bit later. So I've found, as we'll see a bit later on, you sometimes need to quantize these, which you can do in the normal way. So if you wanted to quantize all these here, we could just highlight those, hit Q on the keyboard, and you'll see they will jump to the appropriate position. So it's certainly not a case of all is lost, but it doesn't always get them exactly bang on. In this second example, I wanted to take a look at the effect that different sounds have on the detection. So what I decided to do was to get a hold of a Chopin piano prelude and then just use the chords from that, because they're fairly complicated and it actually does a pretty good job of detecting them. So in fact, you may not know this, but you can drag MIDI onto the chord track and then it will detect and pass the chords which are present there. So I'm just going to do that. So you get this dialogue here. We're going to include bass notes and tensions, and we can see that it does a reasonably good job of detecting the chords which are present in the original MIDI. We can play those back. So if you're interested in that kind of thing, what you can do is if you unmute your chord track, then have, in this case, something such as this ready and monitoring. Then as you play back, we get those chords playing back. So you can see that that's one way of monitoring it, but I'm going to mute that just for the moment. Now, I've got 3 examples here, one of which is on a piano, one of which is on a straightforward kind of sawtooth sound, and one of which is on one of Retrolog's presets, which we'll look at in a second. So in terms of the detection, let's see what it makes of the piano audio. So again, just drag that onto the track. And you can see, while obviously it may appear to be a bewildering amount of chords which are happening, it's not a million miles off. There's definitely some differences. So some of the chords it thinks are slightly different chords, etc. And also it can be a little difficult sometimes to get everything to look the way consistently because of the lengths of these chord names, etc. It doesn't always display them in the same way, but you can see it's certainly not a million miles off. So for instance, here it said A flat, there it said A flat major 7, here it's just said E flat 7, whereas here it's E flat 7 13. Now this is as much as it would detect, so it's not said that it will detect E or a 7/13 chord, etc. So it's doing a reasonable job of detecting it. In fact, it does this better than I expected, given what you may have seen earlier on in the video. Now, let's take a look at doing exactly the same detection, but this time we're going to be doing it with a synth sound. So I'll just give you a quick blast of it. So I'm going to remove those so we don't get too confused by it. And let's just play that back. So you get the idea on that. Now, with the detection of this, we get pretty much the same result. So with that, it seems to work reasonably well. In fact, let's just clear that MIDI result and then place this one on the chord track. And we can see generally pretty similar. The problem is we have this ordering issue, and if we maybe copy that and we'll paste that in there, hopefully that will help us see this in a similar way. So we can see the G chord it thinks is a little bit different. Some of it though, and for the most part, it's working pretty well. Now let's take a look at this next one. So this is a more typical synth sound. So in this particular case, we've got this preset from Retrolog, which is big keys. So you can hear that one's a little bit more confusing because we've got some delay happening in there and then that's overhanging the previous chord. So this is much more of a test of its ability to detect. So let's try this one. And you can see it's had the effect you might think, because there's fewer chords in there as far as it's concerned, even though they're very similar. I think the ones that it's got, it gets about as right as it does normally, but it certainly affects its ability to understand and interpret those chords which are in there. So your mileage can vary considerably depending on the sound that you're using. And obviously these are just bounces. So if you had anything else in there, then that would further confuse matters. So it's clear that while this is pretty incredible, you know, it's something that 20 years ago everybody would have said, oh no, it's just not possible. It will never be able to do this kind of thing. It's certainly not perfect, but it does make a good starting point, and it means that if you're totally at sea, you may be able to work something out MIDI-wise. So this third example is going to be a little more tricky again. So this is the music which is at the end of any of my videos. If you've stayed to the end, you'll know this. And I decided to use this for a number of reasons. Firstly, musically, what's happening is there's some different motion happening, and not all of the chords in the original are filled in. So maybe the third's missing, etc., that kind of thing. Secondly, it's not just big block chords. There's this 8-note rhythm in there, which is happening all the time, and to see whether or not that has any effect on it. And also, thirdly, the sound is filtered, so it hasn't got all those harmonics in there, which may affect the algorithm. And finally, at the end, there's a bit of noise which fades in, because this is the kind of thing you would have if you just were taking a sample from somewhere rather than creating it as a mix down. So we can see there's multiple things happening here. So let's see what it makes of it. Now, initially, that may not make, or may make a lot of sense. It depends, I guess, but let's find out. And now, again, as seen earlier on, a good way to find out what's happening on the chord track is to monitor it. So we've got it unmuted. I'm just going to stick monitor on here. I'm going to mute this track and then play back the chord tracks in their entirety. And let's see what it came up with. Yeah, it's not hideously wrong, but it's certainly not right. So that would definitely need some editing. So this is the kind of thing I think you're probably going to have to do a lot of times with this, is edit it. Now, you can edit the chord track directly and move these things around, but it's probably going to be easier and more immediate to move those chords to a MIDI track and then edit it from there. So that's what we're going to look at now. So it's simply a case of just selecting them and then dragging them. So you can see we get a no entry. I'm going to make sure it starts at 29,110. And now we have these chords represented in this place here. So I can turn monitor off, and I'm going to mute the chord track just to be sure. And now we can start looking at what's happening. And I'm actually going to put the click on, and then we can have a listen to it. Yeah, so you can see, although it's given us the right kind of idea initially, there'd be quite a bit of editing work to do. So to tidy this up, it's not got a million miles off on some of them, but it's made maybe slightly incorrect choices. Now, again, you could go through those options and make it a little better. But let's just look at tidying things up timing-wise. So this chord, for instance, should happen earlier than it does. So let's go back to the chord track and see if we can fix some of this. So that C minor should happen there, and the F should happen here. So going back to the beginning again. So then this chord should happen here. This one should happen here, and then that F should happen there. So let's see how we get on now. Now this next bit is interesting because I've done this a number of times through various versions of this, and it always seems to put in this F sus2, which doesn't really belong in there. So if we listen back to the original at this point, so the G minor should be happening there and the B flat should be happening there. So let's move those across. And then I'm just going to get rid of this. And once again, and again, yeah, the F should be happening there. So let's go from there. And yeah, something should happen there and something else should happen there. But with that tidied up, let's try these, moving them over to our MIDI track to see what we've got. You get the slightly worrying situation where these all disappear momentarily while you're dragging them elsewhere, but there we go. And that's what we end up with as far as it's detected. Now, here I've actually got the original MIDI parts from the song. So what I'm quickly going to do is just split this into the chords and the bass, and then we can just take a quick look at how well it's done. Give it a scorecard. So let's take a quick listen to the two bass parts and see if we get any disparities between them. We can see they're clearly different. Something's not happened here that should do, and the shape of them seems a bit different. But let's see how far off they were. Yeah, so it wasn't a million miles off. So we can see that at the end, this has decided to go C when it should be G, A sharp. It should be a repeat of that again. It picked a different octave for one of these notes, but apart from missing that one note, it hasn't done too badly. Now let's take a listen to the chords. So that may not be as apparent immediately. So let's just overlay these two. And I'm going to zoom in vertically. And there we can see that there is some degree of overlap. But it's certainly not perfect. It's not a million miles out. And it's like it's decided to reharmonize some of it. You know, it's made different choices. So it's certainly not perfect, but the thing I've found with this is mostly that if you've got something where there's filtering happening, etc., it seems to affect the timing. It's as if it can't hear the chord early on in the sound. And clearly with this, it came up with some spurious choices, etc. Once again, you know, we have to remember this is a technology that 20 years ago would have just been the stuff of a madman's dreams, etc. And now it's just in an update to Cubase. It's certainly not perfect. I hope it will be, you know, improved, but it's there and it is usable. So, chords from audio, what do I think? Well, I think it's functional, but it's definitely not perfect. The idea of using the chord track for it is potentially a nice one because it allows you to spread that harmony across all of the tracks of your project. But I think it would have been nice to have the option to put it to a MIDI track or an instrument track directly and get every bit of information out of it that it can detect, and thereby allowing more complicated structures to be uncovered if it's capable of detecting them. But as it is, it's not the audio in, perfect MIDI out solution that I'm sure plenty of people will want. But it's certainly a nice starting point. And this is the kind of thing that I think the processing will improve as time goes on. And hopefully in the next few versions of Cubase, it will improve in terms of the number of chords that it can detect, the ability to detect them, and also the timbres which it can deal with in terms of that detection. As ever, I hope you found this useful, and if you have, please like, subscribe, comment, etc. And also take a look at the other Cubase 12 videos which are on the channel, and we'll see you again soon for more Music Tech Tuition.